Alright guys, what's going on? Let's get this problem started. So when you come across this equation, alright, we're literally looking for the initial height, initial velocity, final height, we're looking for the final velocity. Since the mass of the object is the same, and obviously it's not given, you can cancel out or scribble out all the masses. Then put in your values. 1/2 initial velocity is 15 squared plus gravity times height. We're using 10 for gravity, so gravity is 10. Initial height is 66. Bring down the equal sign. We don't know what the final velocity is. That's our question mark. So we're going to leave this whole thing the same, kind of just about to the very end or last two steps. Gravity times the final height. So 10 times 25. Okay. And then you're going to put everything into your calculator. Okay, 1/2 of 15 squared. Remember, because the mass is not there, this is why it's working like that. This comes out to be 112.5 plus 66 times 10. You're getting 660. And then you're going to bring down the 1/2 VF squared. And good. And then 10 times 25, 250. So let's clean this up a little bit. We want to simplify this side. So 660 plus 112.5. You get 772.5 equals your 1/2 VF squared plus 250. Cool. We want to get this 250 to the other side. We want this whole thing by itself. So we don't do anything until the very, very last step, until this is the only thing on the right side of the equation. So if we subtract 250 from both sides, okay, this is going to leave us here with 500, not 50, it's 522.5 is equal to 1/2 VF squared. To get rid of the 1/2, you have to double both sides. You have to multiply this side by 2 and this side by 2, which leaves over here 1045, and that is going to equal VF squared. To get rid of the square, you got to square root both sides. So we have to square root 1045. So we can hit on this calculator, okay, we can hit the second x squared, second answer, and it will give us that our last calculation, all right, which should have been the 1045. And this kicks out a final velocity of 32.326. We'll round it to 3. So 32.33, and the unit will be in meters per second. Okay. You do the same thing for this problem. You would do the same thing for this problem. All right. Now, for here, you have a force of 200 newtons, and it is pulling the object a distance of 18 meters, but the force is at the angle of 30 degrees. So the work done on the object will be 200 times 18 times cosine of 30. 200 times 18 times cosine of 30, and you're going to get a value here of 3,117.69. Nice. So we got this, good. Great. Now, if you didn't have this exact calculator that has the cosine button directly on it, you could do 200 times your 18 times. And how to get to that, you have to hit second, the yellow right there, trig, press this button, and over on the little arrows until you get to cosine. Then hit enter, and now type in the angle, and we're getting our value here of 3,117.69. And this part of the problem, they want you to do, okay, take the work done, okay, so 3,117.69, and how much power did you do or generate if you pulled this block, all right, 200 meters at 38 degrees, 18, how much power is done, generated in 14 seconds. So you're going to take this answer and divide by 14. So 3,117.69 divided by 14. And we kick out a value here of 222.69, and the unit for power is watts. Okay, so we have a list of our equations. Kinetic energy, 1/2 mv squared. Potential energy, mass times gravity times height. G, we're using 10 meters per second squared. Mechanical energy is the total energy. It's potential plus kinetic. So if you can figure out or know the potential and kinetic at one of these points, that will tell us what the mechanical energy is. And no matter what, those guys would have to add up to that value. So let's take a look. We don't know the velocity down here. We know the mass of the this boulder is 90 kilograms. It's initially dropped from a full height of 20 meters. So potential energy would be mass times gravity times height. So you're doing mass of 90, gravity is 10, height is 20. So 90 times 10 times 20 equals 18,000 joules. Cool. Now, initially, they tell us the height right up here is 0. So the kinetic energy is 1/2 mv squared. 1/2 times 90 times 0 up. This whole thing is 0. So to find the mechanical energy, I can add these two things together. By doing that, all right, let's see, how do I want to write this? Adding these two things together, the mechanical energy is equal to 18,000 joules. So no matter what, if I want to find this, I can do the mechanical energy minus the potential energy to find this kinetic energy. So I can do 18,000 minus 7,200, and this equals 10,800 joules. Okay, so this was one of our answers that we needed to solve for. This was one of the answers we needed to solve for. This was one of the answers we needed to solve for. Now, you had to do this so you could do the subtraction here. All right, cool. And at the bottom, right as it strikes the ground, guys, what is the height? The height right here, even though it's not given, would be 0. So to find the potential energy, m times g times h, 90 was the mass, gravity is 10, height is 0, so this is 0. You know, if you understand that this is h is 0, well, cool. That's got to be 0, which means the kinetic energy, all right, 0 plus whatever this is, has to add up to that 18,000. So this is just going to be 18,000 joules. All right, same thing. You could have done kinetic energy is mechanical energy minus potential So 18,000 minus 0 is still, yeah, you're 18,000. All right, now to find the velocity. The equation at the top, 2 times the kinetic energy divided by the mass. So 2 times kinetic energy of right here, this point, divided by the mass of 90, and then you have to square root it for V. 18,000 times 2 divided by 90 gives us 400. Okay, and we have to, that's not the final answer, you have to square root this. So on these calculators, you can hit second x squared, well, that's how you get to the square root. I forgot what the number was already. That's okay, that's why we can hit second and then answer. As long as you didn't do anything else with that number. I mean, I know it was 400, I was just showing you how to do it. And the velocity comes out to be 20 meters per second. And there you go.